In the vast expanse of our solar system lies Ananke, an irregular moon of Jupiter veiled in mystery. Discovered in 1951 by Seth Barnes Nicholson, Ananke was initially designated as Jupiter 12. It received its name in 1975, drawn from Greek mythology. Ananke personified necessity and fate, embodying the forces shaping the universe. Its discovery added complexity to our understanding of Jupiter and its moons. Ananke's journey around Jupiter is a celestial ballet of elegance and complexity. Unlike the stately, almost clockwork-like orbits of Jupiter's larger moons, Ananke's path is far more eccentric and unpredictable, a testament to the chaotic forces that have shaped its existence. Its orbit is classified as retrograde, meaning it revolves around Jupiter in the opposite direction to the planet's rotation. Instead of tracing a relatively circular path, Ananke follows a highly elliptical trajectory, swinging far out from Jupiter before being drawn back in by the gas giant's immense gravitational pull. This eccentric dance results in Ananke experiencing significant variations in its distance from Jupiter throughout its orbital period. Adding to its orbital complexity, Ananke's path is also highly inclined relative to Jupiter's equatorial plane. While the larger, regular moons of Jupiter orbit in a relatively flat plane, much like the planets in our solar system orbit the Sun, Ananke moves in a tilted plane, as if it were dancing to a different rhythm. This inclined and retrograde orbit sets Ananke apart from Jupiter's inner moons, and suggests that its origins lie elsewhere in the solar system. Rather than forming alongside Jupiter in the early solar nebula, Ananke is thought to be a captured object, ensnared by Jupiter's gravity after a long journey through the depths of space. Ananke, shrouded in the depths of our solar system, reveals itself as a diminutive and enigmatic world. With an estimated diameter of approximately 29.1 kilometers, it pales in comparison to the celestial grandeur of Jupiter's larger moons, such as Ganymede and Callisto. Its surface, a canvas painted with the strokes of countless cosmic collisions, is likely a tapestry of craters, ridges, and vast plains. The exact composition of Ananke remains a subject of scientific inquiry. But its low albedo, a measure of its reflectivity, suggests a surface composed of dark, carbonaceous material, perhaps mixed with silicates and ices. The moon's low albedo indicates that it absorbs a significant portion of the sunlight that falls upon it, reflecting only a small fraction back into space. This contributes to its faint appearance in the night sky, making it a challenging target for even the most powerful telescopes. Observations of Ananke's color in the visible spectrum reveal a reddish hue, further supporting the notion of a surface rich in organic compounds. These compounds, the building blocks of life as we know it, hint at the possibility that Ananke, despite its harsh and distant environment, may harbor the ingredients necessary for life's emergence. Ananke stands as a sentinel within a vast family of celestial fragments known as the Ananke group. This collection of irregular moons, all sharing similar orbital characteristics, is believed to be the remnants of a cataclysmic event that shattered a once larger moon into countless pieces. The Ananke group is characterized by its members' retrograde orbits and their significant inclinations relative to Jupiter's equatorial plane. These shared orbital traits suggest a common origin, a celestial family bound together by the invisible threads of gravity. Within this celestial family, Ananke reigns supreme as the largest member, its gravitational influence holding sway over its smaller siblings. The other members of the Ananke group, each with its own unique story to tell, include Euphorii, Orthosi, Harpalyke, and Praxidike, among others. The study of the Ananke group provides a unique window into the turbulent history of the Jovian system. By analyzing the orbital dynamics and compositions of these moons, scientists can piece together the events that led to their formation and gain insights into the processes that have shaped planetary systems throughout the cosmos. Section 5. A Violent Birth, the Collisional Origins of Ananke and its Kin. The Ananke group stands as a testament to the violent forces that have shaped our solar system. Scientists believe this family of moons was born from a cataclysmic collision, shattering a once-intact moon into fragments. Billions of years ago, a large object strayed too close to Jupiter. Drawn in by Jupiter's gravity, it collided with a moon, shattering it into pieces. The impact released tremendous energy, heating and melting the material. Over time, these fragments coalesced into the irregular moons of the Ananke group. Their varying sizes and shapes reflect their chaotic birth. The Ananke group's similar orbits and spectral properties suggest a common origin. Studying these remnants helps scientists understand the processes shaping our solar system. Section 6. Echoes of the Past. Ananke's role in understanding Jupiter's history. Ananke, despite its small size and distant orbit, holds valuable clues to understanding the tumultuous early history of the Jovian system. As a captured object, Ananke provides insights into the dynamics of the early solar system, when the planets were still clearing their orbital paths and gravitational interactions were commonplace. Its retrograde and inclined orbit suggests that Ananke did not originate in the disk of gas and dust that surrounded the young Jupiter. Instead, it likely formed elsewhere in the solar system, perhaps in the outer regions beyond the giant planets, where icy planetesimals roamed. At some point in its history, Ananke's path intersected with Jupiter's gravitational influence, capturing it into its current orbit. This capture event may have been a relatively gentle process, or it could have been a more violent encounter, disrupting Ananke's original orbit and scattering other objects in the process. By studying Ananke's orbit and composition, scientists can learn about the conditions in the early solar system and the processes that led to the formation and evolution of Jupiter's diverse moon system. As we continue to explore Ananke and its fellow irregular moons, we uncover more pieces of the puzzle, gradually assembling a more complete picture of our solar system's dynamic and complex past. Section 7. The Quest for Knowledge, Exploring Jupiter's Irregular Moons. Ananke is just one member of a vast population of irregular moons that circle Jupiter like a swarm of celestial fireflies. These moons, with their eccentric orbits and diverse compositions, hold tantalizing clues to the history of the Jovian system and the processes that have shaped our solar system. Exploring these distant worlds poses significant challenges, requiring advanced telescopes and sophisticated spacecraft to pierce the veil of distance and darkness. However, the scientific rewards are immense, promising to revolutionize our understanding of planetary formation, moon evolution, and the potential for life beyond Earth. Space agencies around the world are actively planning missions to explore the outer solar system, including the icy moons of Jupiter and Saturn. These missions will utilize a suite of instruments to study the composition, geology, and atmospheres of these enigmatic worlds, searching for signs of past or present life and unlocking the secrets they hold. The European Space Agency's JUICE mission, scheduled to launch in 2023, will study Jupiter's icy moons Ganymede, Callisto, and Europa in detail. While not specifically targeting Ananke, JUICE's observations of Jupiter's magnetosphere and the interactions between the gas giant and its moons will provide valuable context for understanding the dynamics of the Ananke group. Section 8. Unveiling the Secrets, Future Exploration of Ananke. Ananke, despite its scientific significance, remains a relatively unexplored world. Its small size, faintness, and distant orbit make it a challenging target for observation and exploration. However, advances in telescope technology and spacecraft capabilities are opening new windows of opportunity to study this enigmatic moon and unravel its secrets. Future space missions could target Ananke specifically, sending a spacecraft to orbit the moon and study it in detail. Such a mission could map Ananke's surface at high resolution, determine its precise composition, and investigate its internal structure. A lander mission, while more challenging, could provide even greater insights, allowing scientists to analyze Ananke's surface material directly and search for evidence of past geological activity. By studying Ananke up close, we could gain a deeper understanding of its formation, evolution, and potential for harboring the ingredients for life. These future missions, driven by our insatiable thirst for knowledge, will undoubtedly reveal new wonders and deepen our appreciation for the complexity and beauty of our solar system. Ananke, once a dim and distant object, may hold the key to unlocking some of the universe's most profound secrets. Section 9. Conclusion. Ananke's enduring allure in the realm of astronomy. Ananke, a small and distant moon in Jupiter's vast retinue, may seem like an insignificant speck in the grand scheme of the cosmos. However, as we have seen, this enigmatic world holds profound scientific value, offering insights into the formation of planetary systems, the dynamics of celestial mechanics, and the potential for life beyond Earth. Its discovery, naming and subsequent study have enriched our understanding of the Jovian system and the processes that have shaped our solar system. Ananke's irregular orbit, its membership in a family of fragmented moons, and its potential for harboring the building blocks of life all beckon us to explore further, to delve deeper into the mysteries that lie hidden within its cosmic embrace. As we continue to develop new technologies and embark on ambitious space missions, Ananke and its fellow irregular moons will undoubtedly play an increasingly important role in our quest to comprehend the universe and our place within it.